Assalamualaikum warahmatullahi taala wabarakatuh. Today I'm going to solve the example 2.6, which is this example actually dealing with uniform flow and combined flow, or we call it a pair flow, which is a combination of uniform flow and the vortex. So in this problem, a rotating circular cylinder for which of the stream functions and the elastic potential are given as follows. So this is we already know that the psi equal to u naught r 1 minus a squared divided by r squared sine theta minus gamma divided by 2 pi ln r. And then the potential flow phi equal to u theta r 1 plus a squared divided by r squared multiplied by cos theta and then plus gamma divided by 2 pi divided by theta. Okay, question is verified that the leaf is not zero and can be expressed as Fy equal to minus rho u theta gamma. Okay, in this problem, actually, we try to solve and then try to prove that when the uniform flow and the vortex combine, we can have a leaf, even though the drag is equal to zero. Okay, in this problem, first we know that the flow around the cylinders can be written as drag equal to Fy equal to minus 0 to 2 pi cos theta a theta. And for the leaf, we have, sorry, this is not the Fy, but this is the Fx. This is the Fx, and then this is the Fy equal to minus 0 sin theta a theta. Okay, we know that we have these cylinders like this, and then the flow is the cylinder, as in the previous example, and then from here we have, okay, here we have this Fx, and then this Fy. So we're going to prove that this Fy equal to minus rho u naught gamma. Okay, this is what we try to do. Right. Based on these two equations, okay, let's we solve for the drag first. Whether either the drag also have a value or not if we combine the uniform flow, okay, uniform flow u naught and the vortex. Okay, let's we start with the drag first. So for the drag, this is given by x minus 0 pi ds cos theta a d theta. And then what is a ps? So ps is, we can get it from the Bernoulli equation. Then this give you ps equal to p naught plus half rho u naught squared 1 sine theta plus 2 gamma sine theta divided by gamma a u naught minus squared a squared u naught squared. Alright, okay. If we substitute this value of PS into this equation, so we substitute here, so thus we get x equal to minus a b plus 5 a theta sine theta minus um, divided by 4 pi squared a squared u squared pi theta theta. Okay, before I forget, maybe you may ask who first time see this lecture, maybe ask you what is mean by A. Alright, for the cylinder, the A actually the radius of the cylinder. Okay, next, we try to solve this step by step follows in order to avoid from us to make a lot of mistake. So we see that they have some common integration for this cos and sine. For example, this first term, I said that this is the first, and then this one also similar to this, and then we can see sine cos theta. This is maybe so this number two, and then this is also similar with one, and then this one we have so three. So we have two form of integration to the cosines. problem. So we try to solve it one by one, and then we can see that okay, right. First, I solve first. The first is the first one, which is the integrations of from 0 to 2 pi for the cos theta d theta. This is will given to you sine theta from 0 to 2 pi, and then the answer will be 0 because we know that the sine theta and sine 2 pi also equal to 0. And then this is the first one. And then the second one, let's solve this one. So 0 to pi sine theta cos theta d theta. This is equal to sine theta divided by 3 again from 0 to 2 pi. This is the boundary. Alright, if we substitute this, we know that the sine theta 0 is also equal to 0, and then sine 2 pi also equal to 0. Then this again, this is number 2 also equal to 0. And then the number 3, we have 0 to 2 pi sine theta cos theta d theta. This is if we solve this, we have this sine squared theta divided by 2, so 0 to 2 pi. So this again we got a 0. So if you look at this, yeah, we can see that this term is equal to 0, this one equal to 0, this term also equal to 0, and then this part also equal to 0, and then this one also equal to 0. So as a conclusion, what we can say that therefore what we have is, so therefore the drag equal to effect equal to 0. Okay, what does this mean by here? So this means that whatever flow, okay, whatever flow in the x directions, okay, this is means that there is no force in the directions of the uniform flow is the, so means that if the uniform flow like hit like this, then we have the vortex here. We combine these two, this is some sort of a circular cylinder because of we have a vortex, and then whatever, so there is no force or the drag force, maybe because of this force from the front and then from the back are equal. The magnitude of the fx1 and fx2, these two magnitude are equal. You can see that fx1 equal to fx. There is no force. Therefore, there is no force in the direction of uniform flow. Okay, let's we now we continue to the next, which is we try to solve the leaf. Okay, this is what the question asks us to prove that. So for the leaf, again, right here, this is equal to the fy. We stop here. Okay, now we solve this second part, which is f1, which is this is equal to minus 0 to 2 pi ps sin theta a d theta. Okay, as we know that what is the ps here, so we know that this is the ps, this is the ps. You can refer these equations in the Munson books or from the Wileys and any textbook. That because this one I follow the Munson's textbook. Right, here and then okay, we use the similar equations here. Right, we use the similar equations here. The PS that we're going to use is similar as what we use in the drag. So again, we're going to substitute this one. We're going to substitute this PS here. We put it here. The value or other the equation for the PS, then we can get this. So if we put here and then we do some simplification, so the PS will be given like this. So PS, sorry, the leaf, the Fy given, so this is what you have for the Fy. So the Fy equal to minus A. The process is similar when we solve the drag. The different only the equations because the leaf they have a sign which whereas the drag we have a cos. So this is what we have. We solve similar process which is we do step by step to resolve this and then we decompose all these long equations to the simplified like this. Okay, so this try to help you. If you not decompose these equations, if you put like this here, might be difficult for you to solve for some operator for the integrations. It's not in form of this. So you need to decompose first the equations to make it in the simple form like this sin theta d theta. So minus 4 integration from 0 to 2 pi sin 3 theta d theta plus 2 gamma divided by pi a u naught 0 pi sin theta d theta minus 4 pi squared x squared u naught squared integrations of 0 to pi sin theta d theta. Okay, similar to the previous one. So we solve this. We divide. We know that we can see from this equation we have three only three signs operator that we need to solve. So this is similar 1, and then all right, this one also similar. I put this as a number 1, and then this is a number 2, and then this, all right, this is number 3. Okay, this is a sine squared theta. This is sine power of 3 theta. Okay, this is sine squared. You cannot see here. This is a square. This is not right again. All right. Now we solve this one by one. So I try to solve number 1 first. So the integration of sines. So we integrate from 0 to 2 pi sine theta d theta. Okay, in this part we are not solving the fluid mechanics anymore. Now we solve the mathematics. So you need to understand the mathematics in order to solve this problem. Okay, the to polish your fundamental of maths, calculus, and so on. And then this is we got this cos theta. So from 0 to 2 pi, which is this is equal to 0. This is equal to 0. Right? This is equal to 0. All right, next, we solve number 2. Okay, solve number 2. We have the number 2 here. So number 2 gives to us integration from 0 to 2 pi for the sines power of 3 theta d theta. So if we integrate this, what we got is minus cos theta divided by 3 divided by sine squared theta plus 2. Then it's from 0 to 2 pi. Then again, we got a 0 here. Alright. We know that the cos theta is the cos 0 equal to 1, and the cos 2 pi also equal to 1. That's why this one equal to 0. And then this one again, cos 0 equal to sine 0, of course, is this is a 0. Alright. And then, but this one is a, again, if you substitute here and here, you got a minus 2 over 3 plus 2 over 3. Then at the end of the day, you get also 0. Okay. Right. So now we solve for the number 3. So this is integration from 0 to 2 pi for the sine squared theta d theta. So this we got the minus. So this what we got is theta over 2 minus sine 2 theta divided by 4. Again, this is for 0 to 2 pi. And then if you substitute theta equal to 0 and then 2 pi, we know that this term always is 0. Then this from here we got the pi. Okay, because pi minus 0 is a pi. All right, therefore we can substitute now these equations, this pi into these equations. All right, the previous one for the drag we didn't have any form. In this case, we know that this one equal to 0, this one also equal to 0, and then we know that this also equal to 0. How about this? This also equal to 0. The rest that the final equation that we have is this one, right? This have you have a value here. So you need to substitute pi here. So we have the fy here. After this, you have the fy, okay, equal to 2 gamma divided by phi a u naught, okay, phi a u naught, which is multiplied by pi. All right. Okay. In these all equations, actually, we need to multiply by this. If you look at this bracket, so we need to multiply by this. So the whole equations here, we need to multiply by a over 2 rho u naught. So in these equations, we know we can cancel out this a here. Okay, this one also we can cancel out. And then what else we can cancel out? Okay, this I also we can cancel out. And then what else? Okay, u squared u. So the final equations that we have here, this is equal to gamma rho u. So that is a negative because of we have a negative here. Right? We have a negative here. Sorry, we have a negative here. So I need to put that. Okay. So this is the final equations, and then we prove that leaf, we have a leaf in this equation and given for this case, and this is given by this equation fy equal to minus gamma rho u naught. Okay, with that, if you not understand, you can refer back to my notes and then or any textbooks and follow through step by step. Hope that you can understand this problem.